Hey guys, today I'm going to be doing 2019 question 11B from the Leaving Cert chemistry paper. This question is in regards to the equilibrium calculations. So let's just start. For part 1, it asks for a Kc expression. For a Kc expression, the format is always the products on the top and the reactants on the bottom. And they should have square brackets. That's very important. And another very important thing is to put the coefficient as a power, like that. So since there's 2 molecules of BrCl, then this should be squared, okay? And for doing that, you will get 6 marks. So it's a pretty nice 6 marks. Now for part 2, it's actually asking for the percentage decomposition of the reactants to the product. So how much of the reactants actually changes into the product, and it's asking it to the nearest whole number. So for this, I like to use an acronym called ICE. Right, initially, the change, and the equilibrium. So at the start, or initially, we had 0.2 moles of BrCl in a 5-liter container, but we don't need to worry about that yet. However, we will need to take that into consideration later. So 0.2, so we're going to write that down here. And at the start, there's always 0 products because the reactants haven't reacted yet, so that's that. And the change is basically in regards to the ratio. So since there's 2 is to 1, then it would be minus 2 of a certain value that we don't know. It gives, so we're going to call it x, and the reactants give away and the product receives, so that would be plus. So that's just, you could just learn that off, like the reactants is a minus and the product is a plus. Plus x, since it's only 1x, so plus 1x and plus 1x. Okay, now we're going to take into consideration the 5 liters. So the equilibrium would be 0.2 minus 2x, and for this it would just be x and x, but the 5-liter container, so we're going to divide them by 5. Okay, now here we have our values that we're going to sub in to our Kc expression that we got in part 1. Okay, so let's do that here. That would look like this. And the reactants on the bottom. And don't forget the squared. It's really important. Okay, so this multiplies out, so that's x squared over 25. And this, you actually have to go ahead and square it. Yep. So it'd be top by top and the bottom by bottom. So that would give you this. And that would also be over 25 because the 5 would get multiplied by the 5. So this is like squaring a number is basically this multiplied by itself, okay? And because we have the same denominator on both, we could cancel them out and you'd be left with x squared. And we can actually write these two together because they're the same coefficient. The same x. So 4x squared minus 0.8x. Okay, and now we have our Kc expression already filled out, and now we're going to let that equal to the Kc value which we were given in the question, which is 0.22. So we're gonna let that equal to 0.22 and put that over 1, and now you cross multiply. So that means multiplying the 1 by the x squared and the bottom by the 0.22. I'm going to do that here because I run out of space. That would be 1x squared, then multiply 0.22 by 4x squared minus 0.8x plus 0.44. Okay, so that would give you 1x squared. I'm just going to do it with my calculator. 0.88x squared minus 0.176x plus 0.0088. Okay, now we're going to bring everything to one side. So I'm going to bring everything to the side where the x squared is positive. So bring everything to this side by taking away or adding. Okay, so it would give you 0.12x squared okay, and now this looks like a quadratic. So we're going to sub it into the minus b formula, which is minus b plus or minus b squared minus 4ac, but this is in your formula table, so you don't need to worry about it. Okay, this is going to be a, this is going to be b, and this is going to be c. So put that into your calculators, and you get an answer of x is equal to 0.0484, or x is equal to minus 1.51. However, we need to disregard one of these x values because this one's a minus, that can't be. Because you can't give away a minus, because that would just be taking it, if that makes sense. So x is equal to this. So now every time that we had an x here, we're going to sub it in. Well, we were actually asked for the percentage decomposition, so that means how much of this value turned in to these. So that would be these x here. So what you're going to do, that's 1x, so you could just multiply that by 2 or add it twice, same difference. Okay, that would be 0.0484 times 2. Okay, that would be 0.0968. And then you're going to put this over the amount of reactants that went in, which was 0.2. Okay, so that will give you 0.484, and it asks for a percent, so you just multiply that by 100. So it's 48.4%, but it asks for a whole number, so we're just going to round it to 48%. That's your answer for part 2. I'm just going to show you guys here the whole thing. And now we're going to have a look at part 3. It's just a theory-based question. So why does increasing the pressure not change the percentage? So the answer to that is simply because nothing can change the Kc value besides the temperature. So only temperature can change the Kc value, therefore changing the percentage decomposition. So that's it for today. Hope that helped.